Welcome to Back to Basics. In this video, we will be looking at the basics of electromagnetic induction and Faraday's law from grade 11. Electromagnetic induction is the process of producing an EMF or voltage by changing magnetic fields. The EMF can be made in a wire loop by moving it near a fixed magnet or by moving the magnet. Michael Faraday discovered electromagnetic induction when he moved a bar magnet through a coil connected to a galvanometer. He found that the galvanometer needle moved as the magnetic bar passed through the coil. As long as he changed the position of the coil and magnets relative to each other, it did not matter which of the two was moved. The induced EMF or voltage exists only if there is a relative motion between the coil and the magnet. He also found that when the magnet is moved faster, then the amount EMF induced was found to be higher. This is shown by larger deflections of the needle on the galvanometer. He also found that when the number of turns of wire is increased, the amount of EMF induced is found to be higher, showed by the larger movements of the galvanometer. He also found that when he increased magnetic strength, the amount of EMF induced is found to be higher. Magnetic field lines is also known as flux density. The more field lines, the greater the flux density. So flux density is like the thickness of magnetism. Magnetic flux is given by the equation phi is equal to B times A times cos of the angle between the field and the axis of the loop of wire. Magnetic flux linkage, or phi, is measured by Webers. Faraday's law of electromagnetic induction states that whenever there is a change in the magnetic field linked with a conductor, a potential difference is induced, the magnitude of which is directly proportional to the rate of change of the magnetic fields linked with the conductor. This can be stated mathematically as EMF, or epsilon, is equal to negative n times the change in flux linkage over the change in time. The minus sign indicates direction and that the induced EMF tends to oppose the change in magnetic flux. This gives us a number of useful relationships, that the voltage that is induced depends on the rate of change of magnetic flux linkage. Faraday's law is most useful in calculating the voltage produced in a coil where there is a change in magnetic field. It also allows us to figure out how to alter the outcome of our actions. So the changes then could be made to make this coil generate more electricity are easier to figure out. There are three parts to this equation. The EMF is directly proportional to the number of turns. It is directly proportional to the change in flux. It is also inversely proportional to the time taken to change the field. So, more coils, more flux linkage, and faster changes to the fields result in higher EMF. So where in the rotation of this coil do you think is the greatest change of flux? When the coil has the flux flowing directly through it, the least amount of change is occurring. So the amount of voltage or EMF is at minimum. At this position, the wires are rapidly changing. How much flux linkage is occurring? So the maximum amount of EMF is generated. If a coil is spun in a magnetic field, the flux through the coil changes like this graph. The flux through the coil is greatest when the coil is perpendicular to the field and zero when the coil is parallel to the field. If the coil keeps spinning, the flux varies like a sine curve. In order to get the induced EMF versus time graph, the gradient of the sine graph is taken as EMF is equal to the rate of change in magnetic flux. The first slope is positive, so multiplied by the negative, it is below the time axis. The gradient of a peak is zero. That means no change in flux and no EMF. When the flux graph is steepest downwards, the EMF is the most positive. See if you can pause this set of graphs and explain it to a friend. This is perhaps the trickiest part of electrodynamics. What about changing this device to do better? The water falling makes the magnet spin and change the field. Well, according to Faraday's three relationships, all we have to do is add more coils, spin the coils faster to reduce time, and naturally use stronger magnets. Handy information when making generators of electrical power.